Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss few examples on permutations with repetitions on numbers. In our last class, we clearly discussed few examples on permutations with repetitions on alphabets. And in our previous classes, we have done some examples permutations without repetitions on numbers. So if you have the previous classes knowledge, understanding this is very easy to. You can easily catch the concept. So please watch our previous classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, so our explanation is also completely based on the assumption you already have the previous knowledge. So coming here, these are the numbers 2, 3, 6, 6, 7. So using this set of numbers, you need to find how many total permutations possible. Permutation means the number of ways you are going to arrange these numbers. So these type of examples done previously, but here we are having repetition. Without repetition, we have done some examples. So once if you are having repetitions, these 5 digits can be placed in 5 positions in 5 factorial ways. But if you have repetitions, what's the formula? What's the formula for repetitions? It's n factorial by r factorial. Here 6 is repeated 2 times, that's why n is 5. Total how many digits are there? 5. 5 factorial by 2 factorial. This is the total permutations possible using these 5 digits. Total ways you are going to arrange these digits in 5 positions using is 5 factorial by 2 factorial. Coming to the second question, what are the even numbers possible using these 5 digits? Even numbers possible means you can place in the last digit position, you can place either 2, 6, 6. So how many even numbers are there in the given digits? 2 is even, 6 is even, but 6 is, we are having 6 2 times. Placing 6 2 times will not give you effect. So you can place only one time. So in the last digit, in the last position, you can place either 2 or 6. So, but you have to, the point you need to understand here, you have to do it separately. For 2, what are the permutations? For 6, what are the permutations? Why we need to do it separately? Because 6 is repeated 2 times. Placing 6 here gives you different permutations. Placing 2 here gives you different permutations. Why? Let's try to understand that. Suppose in the last position, if you place 2, what are the remaining digits we are having? If you place 2 in the last position, remaining digits are 3, 6, 6, 7. 4 digits remain and these 4 digits should be placed in 4 positions, but here 6 is repeated. So that's why if you place 2 in the last position, your permutations are 4 factorial by 2 factorial. But what happens if you place 6 here? If you place 1 6 here, what are the remaining digits that you have? 2, 3, 6, 7. Repetitions are not there. The way you solve the permutations without repetitions is different. So that's why if you place 6 here, it is just 4 factorial. And these 2 permutations are either this permutations or this permutation. So we go with plus. Why we go with plus multiple times we discussed in our previous classes. That is 4 factorial by 2 factorial plus 4 factorial. These are the total permutations, total even numbers possible with the given numbers 2, 3, 6, 6, 7. Now coming to the very next one, how many odd numbers are possible? Odd numbers means in the last position you have to place what are the odd numbers that are available here? 3 and 7. So both are, we don't have any repetitions here. 3, 7, it's unique. So this in the last position you can place either 3 or 7. So total 2 chances are there. 2 multiplied by, if you place 3 here, what are the remaining digits we are having? 2, 6, 6, 7. If you place 7 here, 2, 6, 2, 3, 6, 6. 6, 6 is present in both the cases. So repetitions are available in both the cases. That's why 2 multiplied by remaining 4 positions can be filled with 4 factorial by 2 factorial because 6, 6 is present in both the cases. So total possible odd numbers are 2 multiplied by 4 factorial by 2 factorial. If you cancel 2 factorial and 2, 4 factorial is the output. Now coming to the last question, what are the, you have to place even digits occupy odd places. Whatever the even digits we are having here, what are the even digits we are having? 266 are the even digits. How many even digits are there? 3 even digits are there. These should be placed in odd places. So 5 digits can be placed in 5 positions, first position, second position, third position, fourth position, fifth position. What are the odd positions? 1, 3, 5 is the odd positions. In these 3 positions, you have to place 266. So 3 digits placed in 3 positions, but 6 is repeated, which is 3 factorial by 2 factorial. That is 3 factorial by 2 factorial. So by placing these 3 digits in these 3 positions, remaining 2 positions, second and fourth position are the even positions. In the even positions, you can place odd numbers, 3 and 7. So 3 factorial by 2 factorial multiplied by 2 factorial. Two digits placed in 2 positions in 2 factorial ways. Why multiplication here? So hoping that you already know why we are using multiplication here. This is the basic thing we discussed in our first class of permutations and combinations. So 3 factorial by 2 factorial multiplied by 2 factorial. This is the total number of possibilities. 2 factorial, you can cancel it, and the final answer is 3 factorial. Hope you understand these examples. In our next class, we do some more examples on numbers. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.